All right, ready to dive into something pretty mind-boggling.
Always.
This time, we're going underground, like way underground, into the hidden world of groundwater.
Sounds intriguing.
We're talking water that can travel, get this, hundreds of miles underground,
Wow.
sometimes taking like up to 100,000 years to resurface.
Seriously. 100,000 years.
Yeah, it's a completely different time scale than what we're used to dealing with, Really puts things into perspective.
It really does. Makes you think about all the water we use every day, where it came from, how long it took to get here.
Exactly. And we've got some really groundbreaking research to help us understand that journey a little better.
Oh, yeah.
A brand new study just came out of Princeton in the University of Arizona,
Nice.
published in Nature Water.
Okay.
They actually mapped groundwater flow
Oh,
across the entire continental U.S.,
the whole U.S.
a whole thing,
Yeah.
using this incredible high-resolution hydrological simulation.
So they basically created like an underground GPS for water.
Pretty much.
That's wild. And they covered, what, millions of square miles?
Yeah, over 3 million to be exact.
That's a massive undertaking.
It is. It's actually the first time we've been able to see this kind of detailed continental scale picture of how groundwater moves. So much has been hidden from view until now.
I can imagine.
So, what we want to do in this deep dive is really unpack this research. See what it can tell us about this hidden journey of water beneath our feet.
Yeah, let's uncover some of those secrets.
Maybe even find a few surprises along the way.
I'm sure there will be plenty of those.
For sure. So, one of the most mind-blowing things that this study shows is just how far groundwater can travel.
Okay.
We're talking distances up to 100 miles before it resurfaces.
100 miles.
100 miles. Imagine that, like a raindrop falling in Philadelphia, ending up in New York City.
Wow. That completely changes how we usually picture water moving, doesn't it? I mean, we think of rivers and streams flowing above ground.
Right.
But this is like a whole other network happening below the surface.
Totally. It's like a vast interconnected web of underground highways.
Highways of water.
Exactly. Carrying water across incredible distances. The researchers in the study, they actually traced a specific flow path
Really?
along the base of the Rocky Mountains.
Yeah.
And it stretched for, get this, 148 miles.
148 miles.
Isn't that crazy?
A long way.
It makes you wonder, like, where does our water actually come from?
Right. Like, is our whole understanding of watersheds about to change because of this?
Exactly. I mean, we have to be thinking beyond these traditional boundaries now.
Definitely. And one of the things that this study really highlights is this concept of base flow.
Base flow.
Yeah. Have you ever noticed how even when it hasn't rained in a while, there's still water flowing in streams and rivers?
Oh, yeah, for sure. Always wondered about that.
Right. Well, a lot of that water, it's coming from groundwater. It's slowly seeping into those surface streams.
So it's the groundwater that's keeping those waterways alive, even during dry spells.
Exactly. So that, seemingly fresh, babbling brook that you see could actually be carrying water that fell as rain like decades, maybe even centuries ago.
Whoa, so even in the middle of a city, the water in that little park stream could have originated hundreds of miles away, maybe even from another state.
It's totally possible. And that actually brings us to another key finding from this study, interconnectedness.
Interconnectedness, okay.
The researchers discovered that, get this, nearly 90% of U.S. watersheds, they're actually connected underground.
So it's like one giant underground water system.
Pretty much. Water doesn't really respect state boundaries, right? It moves from one watershed to another through these intricate underground networks.
This is where it starts to get really interesting. And maybe a little concerning, too.
How so?
Well, I mean, what are the implications of this interconnectedness? Like, if there's contamination in one area, could it spread much further than we previously thought?
Oh, absolutely. Think about pollutants like nitrates from fertilizers or PFAS, those forever chemicals that are so hard to break down. Right.
If those get to the groundwater, well, they can travel much further now, potentially affecting water quality in areas far from the original source.
So it's like this ripple effect underground.
Yeah.
Potentially impacting drinking water sources and ecosystems across huge distances.
Exactly. And this research is really pushing us to think about groundwater management on a much larger scale. We can't just focus on isolated wells or aquifers anymore.
Right.
We have to consider the whole interconnected system.
This is really making me rethink some of my assumptions about groundwater. I always pictured it as these separate, isolated pockets beneath the surface.
Yeah, a lot of people do.
But it seems like it's much more dynamic. and
Right.
interconnected. it would be.
Absolutely. And there's another finding from this research that might surprise you, even more so than these travel distances we've been talking about.
Uh-huh.
It has to do with the depth of these aquifers
Mm.
and their connection to the surface. So the study found that deep aquifers, the ones like 10 to 100 meters below the surface.
Those are actually contributing a lot to stream flow.
Really?
More than we thought, actually.
Hold on. I thought deep aquifers were like pretty isolated from the surface, like down there doing their own thing, totally separate from,
Uh-huh.
those babbling brooks we were talking about.
That's a pretty common thought, and this research is kind of changing that idea.
Interesting.
What they found is that in over half the areas they looked at,
Okay.
deep groundwater was contributing more than half the base flow to streams and rivers.
More than half.
Yeah.
So even like a seemingly shallow creek could be getting most of its water from these
Yeah.
deep, ancient sources.
Exactly.
That's pretty amazing.
It is, and it seems like this is especially true in areas with, like, steep topography, like the Rocky Mountains or the Appalachians.
So why is the depth so important, especially in those mountainous regions? What's the connection between those deep aquifers and the water up top?
It all has to do with how water moves through the landscape, you know?
Right.
Think about mountains, lots of elevation change, right? Creates this strong pull on groundwater.
Okay.
That pull basically draws water from deep aquifers upwards toward the surface,
Interesting.
where it eventually discharges into, streams and rivers.
So it's almost like those deep aquifers are like
Yeah.
giant underground reservoirs constantly replenishing the water systems we see above ground,
Exactly.
even in places where you wouldn't really expect it.
Right.
Wow. Okay, so let's talk about that. So what factor?
Yeah.
Why should people listening to this care about these deep hidden connections? What's the real world significance of all this?
Well, I mean, groundwater is a vital resource for millions of people, right? Used for drinking water, irrigation, industry. In fact, like half the U.S. population relies on groundwater for their drinking water.
It's true. And we've been hearing a lot about groundwater depletion lately. So if we're using it faster than it can be replenished, and now we know these deep aquifers play such a big role,
Yeah.
that's got to raise some red flags.
It does. And this research really drives home the need for, sustainable management practices.
Right.
We can't just keep pumping groundwater without thinking about the long-term impact.
Yeah.
Especially when it comes to these deep, ancient reserves that take so long to replenish naturally.
And what about pollution? Earlier we were talking about those underground ripple effects.
Right.
I mean, if contaminants are getting into deep aquifers, that seems even more worrying now.
Yeah, it really adds another layer of complexity to the whole thing.
For sure.
Understanding how groundwater flows, especially at these deeper levels, is crucial if we want to protect those drinking water sources.
Makes sense.
We need to know where contaminants are coming from, where they're going, and how to prevent them from spreading further.
Right. And then there's climate change.
Oh, yeah.
How does this research, how does it play into how a changing climate might impact these systems?
That's a big question, and it's one that scientists are looking into as rainfall patterns change and temperatures rise. It's bound to have some kind of significant impact on groundwater recharge rates, right? How quickly those aquifers are replenished and the overall flow patterns.
Right.
This study gives us a really crucial baseline for understanding how these systems work, which is essential for predicting and adapting to the potential impacts of climate change on this precious resource.
This is all so fascinating.
It is.
I got to admit, like, before this whole deep dive thing, I had such a, simple view of groundwater.
Yeah.
I never realized how dynamic it is, interconnected, and just how vital it is to our lives.
It's amazing, isn't it?
It really is.
And honestly, what we've talked about today,
yeah.
just scratching the surface, there's still so much we don't know about this whole hidden world beneath our feet.
But thanks to research like this,
Right.
we're starting to uncover some of those secrets.
We are.
And that's a huge step toward, managing it wisely and protecting it for the future.
Absolutely. And it makes you wonder, right? If a single drop of water can travel hundreds of miles underground, crossing state lines, maybe even international borders, how does that change how we approach managing this precious resource?
Yeah. It's a powerful question.
Really pushes us to think beyond those traditional boundaries.
Totally. And those political lines, too, right, when it comes to water management.
For sure, can't manage groundwater in isolation anymore.
Right.
This research just shows how interconnected everything is.
It does.
We need like a more holistic approach.
Yeah.
One that considers that whole water cycle.
Right, from, rainfall and snowmelt to
Mhm.
surface runoff and those deep aquifers.
Absolutely.
So it's not just about individual wells or, local regulations.
Nope,
We got to be thinking bigger,
we do.
recognizing that what happens in one place can impact water resources hundreds of miles away.
That's right. And that responsibility, well, it falls on all of us.
Yeah.
Not just scientists and policymakers. We all got to play a role in protecting this, vital resource for the future.
Absolutely.
Whether it's conserving water at home, supporting sustainable agriculture, or, advocating for policies that protect our water resources,
Yeah.
every action counts.
Will said, this deep dive,
Mm-hmm.
it's been so eye-opening.
I agree.
I feel like I have a whole new appreciation for groundwater.
Yeah.
How complex it is and how important it is.
It's not just something we can take for granted.
Definitely not. It's like this dynamic,
Yeah.
interconnected system.
Keeps everything going.
Yeah, that sustains life as we know it.
I couldn't agree more. And for anyone who wants to really dive deep into
Yeah.
this whole world,
Yeah.
I'd recommend checking out that full study.
In Nature Water.
Yeah. Packed with incredible insights, even if you're not a scientist.
Awesome. Well, thanks for guiding us through this incredible journey. I've got a lot to think about now.
Happy to do it. Glad you enjoyed it.
And to all our listeners, thanks for joining us on this deep dive. We hope you've come back up with a new appreciation for all those hidden wonders beneath our feet.
Absolutely.
Until next time, keep exploring, keep learning, and keep those deep dives going.